There really isn't anything that special about Earth except life. If we imagine a visiting alien species, we can make some assumptions based entirely on the fact that they got here at all. We can assume they are capable of interstellar travel, since it's pretty unlikely another space-capable species is hiding in our solar system. That's pretty impressive right there, and I'm assuming subluminal flight because FTL is sci-fi. The level of technological mastery necessary to move living beings between stars is as distant to us as Apollo was to an ape pondering birds in flight. A species even capable of sending an interstellar probe has at least mastered propulsion and navigation that are only theoretical. If they come in person, it applies a mastery of systems necessary to maintain their biological functions in ways that we're not even clear possible for human beings. I think it's safe to assume they would be so far beyond our technology that our grandest scales of engineering would be a quaint curiosity. So, what might such a visiting species want with Earth? Maybe resources. Presumably, any technology will require resources, and those resources will consist of various forms of energy and matter, but there really aren't any resources unique to Earth or even the Sol system. There are no unique raw energy or matter resources on Earth that couldn't be acquired in most solar systems and from places with less atmosphere and gravity. The common sci-fi trope of liquid water is just hilariously absurd. It's just not a hard molecule to find, change the phase of, or just make. Pulling water out of a gravitational well as deep as Earth is as efficient as hauling ice from the North Pole to cool beer in Ecuador. But even metals, radioactive material, even complex crystals created by intense geologic processes would be far more efficient to extract and synthesize from materials and processes available in lower gravity and less atmosphere for a species with interstellar technology. I think it's safe to rule out any kind of physical resource as a motive for a visiting species to make the trip to our particular corner of space. So maybe it's not just resources, maybe it's the real estate. Earth's unique orbital or gravitational and or atmospheric characteristics. Well, I guess that's not inconceivable, but it would imply the visiting species developed on a planet extremely similar to Earth and is looking to expand or relocate. Relocation scenarios seem far less likely than expansion for obvious reasons, but even that assumes the species' expansion requires or highly values planets like Earth for some reason. It also assumes carbon-based Earth analog life is relatively common in the universe, otherwise it's extremely unlikely there would be another civilization nearby enough to take advantage of Earth. Or I guess it could imply it's not common, but one particular carbon-based Earth analog civilization beat us to becoming spacefaring conquerors. We can't rule out that Earth is a uniquely valuable spot, and thinking through plausible scenarios, or plausible sounding scenarios of Earth's value to alien life is fertile ground for sci-fi, but I think it's built on way too many anthropic assumptions about the universe. Also, I really think that species that expand beyond their planet of origin trend towards existence in lower gravity wells, but I'll get into the reasoning for that another time. Also, if they do want the planet, it's theirs. That's another great well for sci-fi, but there's no version of humans versus interstellar aliens that want Earth that doesn't end with Earth having a new name that we can't pronounce, and it doesn't matter because we won't be around to pronounce it. We like to make analogies to Columbus or other great Earth voyages and encounters between distant cultures, but those comparisons are ludicrously inadequate. The whole thing ignores that the Columbian Exchange was almost entirely cultural. From a biological perspective, just not that much happened. Continents traded a few species of plants and animals, and it jostled a few ecosystems pretty hard. But there were humans on both continents before and after the exchange. It was just a little migration. If another advanced species wanted the planet, they'd just selectively delete parts of the entire Earth ecosystem. There'd be no romantic resistance. They just exterminate us from orbit. So we can just kind of move past that whole thing. It requires some insane assumptions about alien circumstances and motivations for visiting anyway. And if it happens, it'll be as inevitable and complete as getting wiped out by a rogue black hole or something. So if it's not the location and it's not the stuff, what's left? Well, us, of course. Us, being everyone that lives on Earth, and everyone being every living thing. We'd probably like to think humans are the most interesting thing on the planet, and we do some notable things, but I'm not sure we're interesting enough to justify the kind of effort needed for interstellar travel, especially not in person. We might be of interest to an alien anthropologist, whatever they call themselves, but I don't know what a species advanced enough to achieve interstellar travel would expect to learn communicating directly with us, so I'd assume they'd be satisfied with passive remote observation to learn about human beings. And if they can survive or reliably maintain organization across the time necessary for interstellar travel, they're probably in no hurry to learn anything about us. That would incentivize contact. So I'm thinking if humans are a subject of interest at all, we only justify a little remote data collection. They're not sending an envoy to welcome us to the universe and ask us how we're enjoying consciousness or anything. The really interesting thing about us is the rich complexity and potential utility of self-assembling and reproducing biological structures that pervade the environment of Earth. Earth has been running a kind of brute force molecular algorithm for a few billion years now. The output of that process is life, and it's a pretty impressive collection of data about how matter works, or how to make matter work. Analyzing life may be a highly efficient way to gain information about available molecular interactions. Maybe Earth is an alien bioengineering data goldmine. A species capable of interstellar flight would very likely have extensive computational technology. They may have mastered quantum computing or created neural networks that defy our understanding of machine intelligence, but their computation will be limited by the same kinds of hard physical limits that limit their velocity through space. They will not have infinite computational capacity. And even with our most optimistic visions of quantum computing, if you want to fully simulate the universe and every interaction in it, you still need at least 1 qubit for every particle in the universe. Of course, there's a lot of redundancy there, so maybe an optimization process you could find more with less. But against the infinite possibilities of the universe, anything less than infinite computation may just be woefully inadequate. And of course, even with extremely fast computation, you still need time. I'm not even sure how to build a model to speculate on the computations necessary to fully simulate a biological system as ancient or complex as Earth's. If a species has an interest in knowing every possible useful molecular interaction, it may be simpler and more efficient to venture out to find new and novel examples of functioning molecular interactions in the vastness of space than build and run the simulations necessary to uncover every possible interaction. Matter itself may be the most efficient computational system to simulate the interactions of matter. If this is the case, then even advanced civilizations may find value in studying the output of long-running processes of interaction, such as evolution. So, if an alien ever abducts you and probes your butt, don't take it personally. They're probably more interested in your gut flora than you.